Well, hello and welcome back to another episode of programming course. I had a huge absence, I know, but as I said before, I'm recording this series on my spare time, so I had a little bit of, I was a bit short on the spare times. So, without further ado, let's clear all the things from the previous episode and start the fresh one. Imagine a function that you want to return a list, but each time you're gonna need another element of that list. You know, like. Imagine in the function you have a list like the numbers. Let me just comment this area to write this stuff here. This actually doesn't count as code. This is called the multi-line comment, which Python just ignores it. It starts with three double quotation and ends with the same three double quotations. Imagine a list that you have something like 2, 4, 6, 8, 10, all the even numbers up to no, just imagine it's only up to 20. I want to have a limited list for this for this example, and then we're gonna need to go all the way up to say 1000. So in the first scenario, when the list is compressed, you can just create a loop to just do that for you, like for I in a range of say 20 should be 21, because it starts with 0. We can say just start with 2 and end with 21, because if we say 20 it goes only up to 19, and the S step, which is the third argument here, is 2, which it goes 2 2 2. At in the which iteration it just adds 2 units to the previous step. So let's just print I, and if I run this, I just can see 2 all the way up to 20, just like I wanted to. But this is not a function. I just wanted a function to return those values. In the function version, we can use my function, whatever. And I couldn't just return I, because if I came here and say for everything in my function, print that thing, it just returns a number, and the number is not iterable as it says, so we are not able to iterate. And if we just create a list, you say like result is equal to an empty list, and result append I, and then return the result. In this way, we can just create a list beforehand and just return the values at once. But this is not what we are looking to. But this is not something that we want to, and we are not seeking to do that. We just want to return those numbers one number at a time. In this scenario, the Python introduces a new keyword called yield. If you yield a value, it just kind of works like return, but but it doesn't end the function. It just it pauses. Imagine like I just say return hello and then say return I'm Siavush and I am learning Python here, maybe teaching, but I'm actually learning, and say return bye. And if I just run this, it only says the hello part, and because the hello is a string and everything is in the string just kind of considered to be a character, it just prints the characters one character at a time. But what about the others? It doesn't work like that. But if we use yield instead of return, it returns one of the results at a time. And for the second time we use this function, it just returns the second value of it. It just kind of remembers the state of the function. It just doesn't end the function. It goes all the way until the function reaches the bottom of the ocean. Let's start with something similar. Say let's imagine I is equal to 1 and maybe 2. We just want to write this second scenario here, and let's say while the I is less or equal to 1000, yield I and then add I by 2. And if we just run that, we can say we have all those values here. So what was the alternative here? It has some benefits because it doesn't generate the whole list beforehand, and it just saves a lot of memories, and it is more readable, and actually it doesn't end the function itself. And actually, if I remove this condition here and just say true instead of a condition, it goes forever. And if I bring that let's just run this way, and it just goes all the way up to infinity, and I have to kind of force it to break. If I add this condition here that says if the value is greater or equal to 1000, just break it. It has two actually semantic errors, which doesn't which we couldn't print 1000 because the break would be called before the print, so it would never reach the print section. And by this approach, we kind of be able to print those values. But if we start this again, you kind of can see. Let me just clear the terminal. Yeah. And if you just pay attention, you can see that this starts here, goes all the way up to 1000. Yeah, just right there, and then it starts again. So when we are done with that function actually goes out of the memory and it just ends. And if we just wanted to kind of see this behavior, on the normal programming without the yield keyword. Actually, we could just replace this yield with return, and we didn't need that because we kind of needed that, but we had to move that I to a more, to say the upper score or another scope. I'm actually not sure what the phenomenon of that, but this is the global scope, which means everything you actually define that here, not inside any classes or functions, it would be available everywhere at your program. The name is the global scope, and if we wanted to use that, we kind of say the global I. We need that global I here. So the I is now a part of this, and because we just add this by 2, we shall start with 0. And if we do that again, it says we are iterating on functions, which is not something we want. We have to print the value of this, or we can just say the underline is equal to this, and it should be in the range of 1,000, 10,000, doesn't matter actually. And we don't need the second one. We can just copy this, and we can kind of see the same behavior as before, but this approach is with the global variable, which is I in this case. But this is not a proper solution. This is not a readable code, and this is not admired. And as you can see, I just accidentally closed the terminal. Let's delete everything and just start over. And as you can see that we have only one repetition of this, and the second repetition doesn't exist here. The reason is, for the second time that we are calling that function, it just returns a value greater than 1,000, because the value of I never reset to 0, unless if we just say I is equal to 0 again and do this thing again. In that case, if you do that, you can see that the list starts again, but without that we don't have that behavior here. So you can kind of compare this scenario with the yield function, and you would be able to see how compact and handy is the yield keyword. And the goal of this video was just to introduce you to the yield keyword, and I hope you enjoyed it. If you did, do not forget to like this video at least, because it would help me a lot. And thanks for watching. I hope I see you in the next episode, and as always, take care and keep practicing. See you.